Hello AP Stats students. In this video we are going to continue to look at these probability distributions we introduced in the last video. Remember, a probability distribution is nothing more than just a list of all the different outcomes and the likelihood that they are going to happen. And so what we want to look at today is kind of focus in and say, okay, let's say we did this probability experiment. What would the average value be that we would expect? In other words, if we rolled two dice and we did that a lot of times, what would the average be? What would the standard deviation be of that data set? And so we want to figure out how we can do that by just looking at the probability distribution. So here's an example. Let's go ahead and make a probability distribution out of this. If you haven't read through this, pause the video first, and then we will do that. Okay, so if we were going to make a probability distribution out of this, we would have three different possible outcomes. We have the outcome that they brought nobody for VIP day, they brought one person, and that they brought two people. And so the probability that they brought nobody was 10%, so that would be 0.1. Probability that they brought one person was 60%, and the probability that they brought two VIPs, remember this has to add up to be 1, and so 1 minus 0.6 minus 0.1 gives us 0.3. Okay, so that's the likelihood of each one of those outcomes. So let's just for a minute suppose we had 100 students. Of those 100 students, how many would we expect to bring no VIPs? Well, it's 10%, so 10% of 100, that would be 10 students. Okay, how many would we expect to bring one VIP? 60. And how many would we expect to bring two VIPs? Okay, 30. So in general, how many VIPs would we expect from these 100 students? Well, we would add them up. We've got 10 that brought 0, so that would be a total of 0. Okay, we've got 60 that brought 1, so that would be a total of 60. And then we've got 30 that brought 2, so that would be also a total of 60. So we've got a total of 120 VIPs here at the school for 100 students. Let me not do that just yet. So the answer to this question, how many total VIPs would we expect, would be 120. So how many would we expect per student? Well, there was 100 students, so we would expect 1.2. So the average that we would expect if we did this would be 1.2 VIPs per student. Now that isn't really anything special about being 100. If we had done the same thing for 200 students, yes, these numbers would have changed, but so would have the number we divided by. Or if we did the same thing for 50 students, the numbers over here would have changed, but what we divided by would have changed as well. We would have always gotten this 1.2 value. And so we can create a formula then where we don't have to worry about how many students we have. We're really just looking at the probability of each one of these outcomes happening. And so on your AP statistics formula sheet, you'll see on the front side of this, or what I call the front side of it, the side we've kind of focused on for the most part right now for first semester, you'll see a title where it says probability distribution. Okay, and underneath that it says discrete random variable x, and then it says mean, or mean of x, is equal EX. That EX stands for expected value. In other words, this is what we would expect when we did the experiment. And the way we find that is we take the sum, remember that's what that notation there means, the sum of each variable times the probability that that variable happens. So for example, in our problem up here, we would take 0 times 0.1, which is 0, 1 times 0.6, which is 0.6, 2 times 0.3, which is 0.6. We would add those together, and we would get our expected value of 1.2. So that's what that formula is saying. It's saying multiply the x times the probability, do that for each variable, add them together, and that gives us our expected value. Here in just a minute, we'll return and talk about this standard deviation formula. Okay, let's practice this though. So for number one, go ahead and make a probability distribution here. Okay, what are the two different outcomes? Well, they're going to win $1, so up $1, and the other outcome is that they're going to lose $1. Okay, now let's figure out the probability of each one of those things happening. Now, we previously, in your last video, made a probability distribution for rolling two dice. Looks like this. And so the ones that are highlighted in red here, those are our even ones. And so if we count up the probabilities of these even ones, we get a total of 18 out of 36. And so the probability of winning $1, because we rolled an even number, would be 18 out of 36, or 0.5. Now we could go back and calculate it and find the probability of rolling an odd being 18 out of 36 as well, but we also know that these two outcomes have to add up to be 100%, so that one's also going to be 0.5. So let's see what our expected value would be. we would take x times the probability, so this one would be 0.5, and x times the probability, so this one would be negative 0.5, and then we add those together and we get 0. So that we would consider this a fair game. Okay, nobody's making a profit here. You've got just as much chance to win $1 as you do to lose $1, and nobody's really, not like whoever created this game is making extra money, or the people that play this game are extra money. Everything is fair because the expected value in this game is going to be 0. Okay, go ahead and pause the video here, look at number 2, and see if you can figure out what our expected value for Dwight's beet farm would be. Okay, so we want to make our probability distribution, so our outcomes are 0, 2, 4, 6, 8, or not 8, but 10. Okay, and then we write down the probability for each one. So the probability of 0 was 0.05. Probability of getting 2 pounds was 0.2. Probability of getting 4 pounds was 0.4. Probability of getting 6 pounds was 0.3. And the probability of getting 10 pounds was 0.05. So to find our expected value, we would take each one of these, multiply the x times the probability. And so 0 times 0.05 is 0. 2 times 0.2 is 0.4. 4 times 0.4 is 1.6. 6 times 0.3 is 1.8. And 10 times 0.05 is going to be 0.5. So to find our expected value, or our mean, we just add those together. Okay, we don't have to divide here. The reason why we don't have to divide is because the total of our probabilities is 1. So technically we are dividing. We're just dividing by 1. And of course that doesn't change our answer. So when we add this all together, we get a total of 4.3. So Dwight can expect a yield of 4.3 pounds of beets from each one of his beet plants here. But that is a random variable, meaning that not every plant is going to give him 4.3 pounds. There's going to be some deviation in that number. And so we want to calculate that variability, finding that variance, finding that standard deviation, so that he has an idea of how much it's going to vary. Is it going to be 4.3, but maybe it might go as high as 4.5 or down as low as 4.1? Or is it 4.3 where it might go as high as 7, but maybe go as low as 1? Okay, that makes a difference in how you plan. So remember when we found deviation before, what we did is we took each value and subtracted it from the mean. Okay, then we squared those numbers, added them together, and then took the square root, and that gave us a standard deviation. So we're going to do something similar here. We're going to take each outcome, subtract it from the mean that we just got, but then multiply it by the probability of that particular outcome. We're going to add all those together, and then when we're done, we're going to take the square root. So when you look at this formula, it looks kind of complicated here for standard deviation, but that's exactly what it's telling you to do. Is we're going to take each x value and subtract it from the mean, square it, multiply it by the probability, add all those up, and then take the square root. Okay, so let's see how much variation that Dwight can expect from his beet farm. So we already figured out some of this stuff. This is 0.05, this was 0.2, this was 0.4, this was 0.3, this is 0.05. We were given those numbers. And then we've already multiplied these in the last problem, and we got 0 and 0.4 and 1.6 and 1.8 and 0.5. And when we added all those together over here, we got a mean of 2.3. So that was our expected value. Okay, so now let's finish finding this standard deviation by filling in our table here. So we're going to find the deviation. We're going to take each x value and subtract it from the mean. So in other words, we're going to take 0 minus, that's not 2.3, that's 4.3, minus 4.3. And so when we do, we get negative 4.3. Okay, then we're going to square that value, which is 18.49. And then we're going to multiply it by the probability, because the probability of us getting an 18.49 variation, that only happens 5% of the time. So that's why we want to multiply it by 0.05. And so if we do, we get 0.9245. And I would encourage you to leave as many decimals as you can here, just because it's going to make our answer better at the end. Okay, so go ahead and finish filling out the rest of this chart using that same thing. Finding the deviation by subtracting it from the mean, squaring it, and then multiplying it by the probability. Okay, so what we end up with here is negative 2.3, and we get 5.29, and we get a total of 1.058. Okay, in the next column, just check your work here. You should have had negative 0.3, and then when you squared it, 0.09, and then when you multiplied it by 0.4, 0.036. Okay, and the next one you would take 6 minus 4.3, which is 1.7, Square that, you get 2.89. Multiply it by 0.3, and you get 0.867. And finally, for the last one, you would take 10 minus 4.3, which is 5.7. You would square that, which is 32.49. And you would multiply it by 0.05, and you'd get 1.6245. So our overall variance is just the sum of this column. So we would take 0.9245 plus 1.058 plus 0.036 plus 0.867 plus 1.6245. And when we do, we get 4.51. And again, leave as many decimals there as you can. But that's the variance. The standard deviation is just the square root of that. So we're going to take the square root of 4.51, which means we get the answer of 2.12. Now remember, what that standard deviation tells us is that tells us on average how far are our numbers going to be from our mean. So when we say we have a mean of 4.3 and a standard deviation of 2.12, remember we talked about the fact that if this was normally distributed, we would expect that 60-some% of our trials would be between one standard deviation above and one standard deviation below. Now we don't know for sure that this is normally distributed, but if it was, we would be saying that, okay, well we would expect that, 60% of the time or better, that it's going to be between 4.3 plus 2.12, so in other words about 6.4, or 4.3 minus 2.12, so in other words about 2.2. So 60% of the time, Dwight can expect a yield per plant somewhere between 2 pounds and 6 pounds. That's what we've come up with here as kind of an estimate. Okay, so that's the idea of standard deviation. Okay, I want to give you one more to try. So this is kind of a large set of numbers here, but let's start by coming up with a probability distribution, and then we will get our mean and standard deviation. Okay, so we have three possibilities here. Okay, it looks like only two, but there are three possibilities. So our three possibilities are this. They can win $0, they can win $10,000, or they can win $100,000. Okay, the chance of them winning $0 we'll get to in a second. The chance of them winning $10,000 is 0.1. The chance of them winning $100,000 is 0.01. Okay, so knowing that this is a probability distribution, we can figure out the probability that they win $0. It's 0.89. Okay, so use what we have right there and figure out what our expected value would be. Okay, so remember you're going to multiply these and you're going to add them together. And so when you do, you get an expected value of $2,000. Now, we could create the table like we just did, and that would be fine. But these numbers do get kind of large, so it's probably easier just to do this since there's only three of them to do it on your calculator. So what I want you to type into your calculator is you can type in the deviation, so take 0 minus 2,000 squared times 0.89. Okay, that's our first entry. Okay, plus 10,000 minus 2,000 squared times 0.1. Okay, and then we'll do the last one, so plus 100,000. And of course, if you wanted to go ahead and subtract these in your head, because these are pretty easy to subtract, you could. But 100,000 minus 2,000 squared times 0.01. And then hit equals. And so we've just taken every step we just did in the table and we've consolidated it down to almost the very end. What we're going to get here is going to be our sigma squared. And so when we do that, you should get an answer of a pretty large answer here, 106 million. So 106 million is that answer. And so that's our standard deviation squared. That's our variance. And then our standard deviation would just be the square root of that number, which is $10,295.63. And at first you might think, well, that's a really large variation, but we have a really large deviation in our data set here. It goes from 0 to 100,000, and so the standard deviation of 10,300 isn't that big of a surprise. All right, so at the end of this video today now, you should be able to figure out what the expected value is from a probability distribution, as well as how much deviation or the standard deviation that we would expect in that expected value.